So, good morning, everybody. My name is Andrea, and together with my colleagues Luca and Milo, we are honored of taking care of the first keynote, which goes by the title Digital Twin from Vision to Reality. Before starting, a couple of words about our company. Iveco Group, we are a large group. As you can see, we have a lot of numbers, large numbers. You can look for them online if you want. But more interesting is what we do. You might know Iveco for our trucks, our buses, our light commercial vehicles. Not everyone knows, under the brand FPT, belonging to Iveco Group, we are a provider of powertrain solution, both old conventional, ICE, and electrified, not just for the Iveco branded vehicles, but also for a large array of external customers, both on and off-road. So you might be interested in working with us. Couple of words about us. I represent here Iveco Group. So the group, I have two positions there. I'm both head of innovation, energy and propulsion, meaning everything which offers a movement solution, whether ICE or electrified. And also, I'm head of vehicle projects, where I lead the integration of solutions within the vehicles. Luca works in my team, is head of innovation ePowertrain. And Milo is our special guest. He is CTO and co-founder by Newtwen. Newtwen is a startup that, as you will see, was one of the main enablers in the project we are going to show you. And his presence here is also a testament of our commitment to open innovation, so basically of innovating with the support of partners. Speaking of which, we have a brand for that. It's called Beyond Lab. We have a website. If you are a startup, if you're interested in working with us, you can Google it, and there is a portal. So, but now, without further ado, let's talk about digital twin. So you read here, that's an academic definition of it. And even though, as I told you, at Iveco, we do powertrain, we do truck, buses, let's talk about airplanes. That's because I love airplanes. I fly as an hobby. But beside that, aviation, as you know, is at the forefront of innovation. And aviation is a very cool sector where people tend to do things the right way because the price of doing them wrong is your life. So you can get inspired by that. And one of the oldest examples of digital twin you can see in the world is fly-by-wire. I don't know if you are familiar with the Airbus concept of fly-by-wire, but that basically you have, as you can see there on the left, it's basically an envelope, a digital representation of the plane and of its physical limitations. And this is constantly compared to the input given by the pilot. Whenever the input exceeds the limitation, the plane will correct it. And what's happening here is basically the plane, the digital twin of the plane, is protecting the hundreds of customers sitting at the back of the cockpit. So then we asked ourselves, can we do the same? Can a digital real-time representation of one of our trucks help our customer? And the answer is yes, and not just our customers. We figured out a digital twin can be, I called it here, a guardian angel for our customers, but also for us, for the engineers, for the shareholders, and ultimately also for environment and society. And so this is quite high level, but how do we do that? Well, first of all, we can use a digital real-time representation of the vehicle to protect our customers against unplanned stops. So what really makes our customers mad is when the truck breaks down, they cannot complete their mission. So we are able, thanks to a digital representation, to offer predictive uptime and make sure that the truck calls for service. It doesn't happen unforeseen. But then it can really help us a lot, the engineers. We have, basically nowadays at Iveco, every truck we sell is connected to the network. So we can use basically feedback from the field to integrate what we learn directly in the next design loop. So this increases development speed and ultimately increases the quality for the customer. This obviously also makes happy our sales and service people because they can offer stuff like digital birth certificate and the value of the vehicle is ultimately increased. And most important of all, as you will see, thanks to a digital twin, we are able to increase efficiency. Increase efficiency means reducing CO2, it means ultimately protecting the environment. However, making a real digital copy that runs in real time of the whole vehicle is pretty complicated. Because first of all, you need to imagine that you need a logical representation of your truck. How the different systems connect to each other with common interfaces so that when I have a digital twin of a certain system, it can communicate with the others. We are a large corporation, and so silo happened, and this is where we are working to make sure that all the digital twin work together. But also, convincing the management, this is a big investment, is a challenge. And this is why, and this is also why we're here, because we decided to move from the holistic vision, the whole truck as a digital twin, and create a success story, create something that actually works. And we started from an e-axle. And I leave for that the floor to Luca, who will explain you in detail what he did here, he and his team.
Okay, thank you very much, Andrea. Good morning, everybody. I'm very happy to be here today. And I would like to present how we applied developed the digital twin for our product, in this case, an electrical axle. So for us, a digital twin is not just a tool, it's a sort of complete chain that we are using in order to have a development over the overall product lifecycle of our product. So starting from the concept phase, where we are applying it in the design, simulation, testing, and validation level, where we can reduce the number of testing, thanks to the virtual reality, reduce so the time to market, and also create value optimization for our customer, thanks to the reduction of the R&D cost. Then moving forward to the manufacturing phase, we are using the high fidelity virtual copy of our electrical axle in the end of line test in order to enhance the quality at 0 kilometer, in order to prevent early failures for the assembly line. And then the effect is maximized during the in-field and post-service phase, when our customers are using the product installed on the connected vehicle, as you can see from this image, this visual image. And so the added value for our customer is the uptime, because we can provide them additional service, digital service, that go beyond to the traditional product that we are selling, so the hardware, in order to connect together the system from the cloud and the twin that is running on the edge on the vehicle, so maximizing the uptime for our customer. That, especially for commercial vehicle, is one of the most important KPI, together with the total cost of ownership. And also having this amount of data available and always ready to be analyzed can allow us to enable the sort of digital passport, and so we can also increase the trust for our customer, because they know what they are buying, both in first purchasing, but also in the second life. Now, I would like from concrete results to show you what we did to implement the digital twin. In this case, I would like to present the activity done this year in cooperation with Newtwen, where we created a thermal virtual model, virtual twin of the most important component of our electrical axle, so mainly the electrical motor and the inverter. Here, the challenge is that some area, and especially the most critical area in terms of thermal hotspot of those components, are not accessible via physical sensor, because the motor rotor is spinning, and in the inverter, the critical point is the connection between power modules and the board. So the twin allow us to create a high-level fidelity copy, thermal copy of those components. And thanks to the fact that together with Newtwen, we were able to implement a reduced order model, we give the added value to let run this model, this very accuracy model, on time on the control unit. What allow us to do? Allow us to predict in real time which are the limit of the system in the most critical area. And so, as engineer, we have the possibility to reduce the safety margin that we have during the calibration in order to avoid some issues in terms of reliability and go beyond the conventional performance. Which are the results that we obtained? Here are just two graphs that demonstrate that thanks to the fact that we are able to monitor very well the component in the most critical point, we were able to increase to reduce the safety margin in terms of thermal safety on the critical component, increase the current of the electrical motor up to 20%. That leads an increase of power and torque on the whole rev speed curve of 10 up to 11%. This is very, very important. Same approach we did on the inverter, another use case. Here I think is still more powerful because, as you know, the inverter temperature is really challenging, especially because we need to predict a behavior, the transient behavior that is very, very fast. And so in the graph that you can see here, you can see a demonstration that the twin, that is the magenta line, is able to copy one-to-one the temperature on the power modules of the inverter measured with the infrared camera, while a physical sensor is the blue line, you see, is really slower and also is not able to capture the real temperature. The results also here is that we are able to control the system. We are able to do not overcome the physical real limit of the system in the critical spot, and so we can give more current, so 10%, that means 10% of improvement performance at same hardware, or possibility to use component with lower performance, and so doing a sort of downsizing on the inverter at same performance, maintaining the same, reducing the cost in a range of the 10%. Okay, so this is our some physical results. Now I leave the stage to Milo that will present how Newtwen, with their software and their approach, supported us in this journey. Please, Milo.
Thank you very much. It's a pleasure to be here to communicate our vision on this topic. So what we have seen so far is how we can create accurate physics-based and virtual models for leveraging engineering domain knowledge and test bench data for calibrating these models. But we at Newtwen, we push our research and development beyond this, and this is what we call embedded intelligence. And this concept is mainly composed by two components. On one side, you have real-time models, which basically are models that can provide information, can reconstruct information about quantities that you cannot measure in a production environment. And for example, internal temperature, losses, aging indicators, anomalies. And on the other side, you have the control layer inside the vehicle, which is responsible for operating the system, the whole system architecture in real time. These two areas, these two components are traditionally loosely connected, and they are often orchestrated by completely different engineering teams. Our vision is to tightly connect them into the embedded environment, into the microcontroller unit, so you end up having real-time models that continuously infer and predict unmeasurable quantities and feed them into the control layer. So you couple these two information and you use this information for decision-making control. So it is where this concept of digital twin can finally make an impact at the system level. Once you enable this, then the next question is straightforward, because then you say where you can apply it. And actually, this approach can be applied very transversely on the full vehicle, because it is completely component agnostic. So the methodology is always the same. You prepare a virtual model using engineering domains knowledge, so CAD model, physics information, experience from engineers, and then you compress, reduce this model, and you deploy it into the system itself. This can be applied on electric drives, batteries, cooling systems, heat cabin also. It's something that we are exploring together with Iveco and FPT. And of course, this is a game changer in terms of how we think and design the software at the vehicle level. And this is particularly interesting for OEM because they can start to think really on system level optimization. The software, it is a very important part in this workflow, let's say, in this topic. And they can start to think about how to balance performance, reliability and lifetime of components, not just optimizing locally a single component, but orchestrating them at the system level. And of course, this then enables, so this avoid to design margins component by component and start or let us start to think about the whole system together and also how the software can improve overall the performances of the components that are available in the vehicle, and they operate in real time and they can be orchestrated together. Thank you.
Thank you.
Yeah.
Okay. Some word from my side. Thank you, Milo, for the presentation, but also, yeah, for the great technical contribution in terms of systemic thinking, which I think is one of the crucial things nowadays in everywhere, but especially at large OEMs. So what's next? We started from the e-axle, and actually now we want to move back or move up. We're doing with Newtwen exactly the same thing at battery level. Also here, imagine being able to have a model of the battery running real time. So having the exact temperature at cell level, that's very interesting. Then we want to put the things together with the thermal system of the vehicle, and ultimately the idea is to have the whole truck. But the interesting thing is this. This is something we're already doing. So on the left, you see what Luca showed you. On the right, it's something that in my other team, the vehicle team, we are doing with Newtwen. The idea is the same. So, normally, I don't know if you're familiar with HVAC system, but in the cabin, you have a couple of sensors. They're normally on the air vents, or you have some solar sensor up in the windscreen. And this means that you don't have a real estimation of temperature on the body of the driver. That's very important for us because, for instance, in our light commercial vehicles, we have missions. Imagine the delivery mission, like what Amazon, DHL does. This guy goes in and out the vehicle continuously, and you have a lot of heat loss. So we're applying the same principle, and we want now to have a model running in real time and estimating the temperature on the body of the driver. And now imagine if we can connect the two things. If they speak the same language, we can think of stuff like we use the extra heat generated by the e-axle to heat the battery, or why not to heat the cabin. Often I have to explain this concept of the digital twin to very high management. They are not familiar with technical speaking, and so I always say, imagine if you have an oven and you got one sensor on the door, but you can estimate in real time the temperature on each of the cakes you're baking. So you will be able to turn down the temperature and take off each of the cake before they burn. And that's quite amazing. And this leads me to the last slide, which is, as I told you, I'm responsible also for internal combustion. And this is something that we could learn interestingly from ePowertrain. People think, digital twin is very modern, it's very cool, therefore it must be electric. But it works very well, same concept on internal combustion engines, because the idea is exactly the same, is to be able to run in real time some parameter calculation and simulation in some area of the system, and therefore reducing safety margin and optimizing the way the whole system is managed. Between ICE and electric, there is a thing which is called hybrid. That was abandoned. We thought it had no future. But now it might come back, at least we're thinking about it, and this is where the system becomes very complex, because now you have something electric, something internal combustion, and you want it to work in a way that makes the customer happy, which is complicated. And this is where an approach like the one that we showed you could be very interesting. Speaking of which, tomorrow afternoon, me and Luca, we will be moderating Work Cafe, which is actually about hybridization in heavy transportation. If you want to participate, we are very much looking forward to seeing you there. And yeah, that was it from us. Thank you very much. I think we have 4 minutes and 50 seconds left in case you have questions.